All right, let's talk about Z and T-based confidence intervals using Minitab. What do you want open to work through this lecture video? You're probably going to want the Word document open for the lecture outline. I'm going to be referring to this Word document as we go through this material. And then you also want to open the Minitab file attached with this item, which is 292 CI lecture.mpjx. And all you're going to see in it is one single column on Facebook Friends. Basically, what I have done is I've taken this table of information that you see in the lecture outline, and I have typed it into Minitab for us so we can work with it. All right. So confidence intervals, they are hugely important. In fact, in so much of the output, the analyses that we run in this course, we find confidence intervals in the output. All right, so they stay with us throughout the semester. All right, why do we want to run a confidence interval? And the answer is you want to run a confidence interval for a population parameter when you don't know it. All right, so for example, we may not know the population mean mu, and we want to kind of estimate where mu might be. And so what we're going to do is we're going to go take a sample, and we're going to build a fence around this sample. Okay, and let's just go ahead and scroll down here for a second and take a look at E here, margin of error. All right, so the width of the fence is referred to as the margin of error. And what influences the width of the fence is something called a critical value. That's what you see here with the Z sub C. All right, so we're going to right now call that a critical value. The standard deviation of the population, sigma, and N, the sample size. All right, so these factors work together to decide how wide of a fence we need to say with some level of confidence that mu is in this interval. Okay, so let's back up for a second. All right, let's go back all the way up here to A, the point estimate. The point estimate is the starting place for this interval. All right, so again, I said that we want to estimate mu, the population mean. We go get a sample. So what are we going to calculate on this sample as a starting place for an estimate for the population mean? And what I hope you're thinking is the sample mean. Okay, and so we're going to calculate X bar, or the sample mean, as a point estimate or starting place for this confidence interval. Okay, and then what we want to do once we have this point estimate, all right, is figure out how confident we want to be. And there is a relationship between the confidence and the critical value. Okay, so let's work through part C here. Okay, so let's talk about this. All right, so in Minitab Express, we can either be 90% confident, 95% confident, or 99% confident. All right, we're going to choose one of these three. And there is a related Z-score for each of these confidence levels. Now, when it comes time to take the quiz or the first exam, you're going to want these Z-scores handy, or you're going to want to know how to find them in Minitab. So let me show you very quickly how to find these Z-scores in Minitab given some confidence level. All right, so we're going to go over to probability, distribution plot, display probability. All right, we are dealing with z-scores, so our mean and standard deviation are 0, 1. All right, and we have here 90%. 90% is the area between two symmetric z's. Okay, so again, it's the area shaded in the middle between a positive and negative z-score. All right, so in terms of what we're going to choose here, we're actually going to choose equal tails. And the probability is going to be 1 minus the confidence. All right, so 1 minus the confidence here would be 0.10, and we say okay. And notice that we see negative 1.645 and positive 1.645, all right? And the critical value is always the positive z-score, all right? We can do the same thing for 95% confidence. That just changes the probability to 0.05. And what we'll see here is 1.96, as I have denoted in the table. And then lastly, we could do the same thing for 99% confidence, which changes the probability to 0.01. And that gives us our 2.575. Now, you would say here, well, Angie, doesn't that round up to 2.576? Yes, it does, but these are considered the critical Z's for this level of confidence, because we used to have to use z-tables, and you guys are so lucky to not have to use paper z-tables to look up all of these numbers. All right, so now let's say that on the quiz or the test you happen to use 2.576. That's a-okay. I am well aware how close the answers need to be. All right, so again, that would be fine. All right, so again, we are going to take, all right, our point estimate. We're going to take our level of confidence, which gives us a critical value, our standard deviation, and our sample size, and we're going to plug this into Minitab, and Minitab is going to calculate the margin of error and give us the confidence interval. All right, so let's do one of these together with the Facebook example. Now, going back to Facebook for a second, what do we have here? We have the number of friends for 40 users on Facebook. Okay, so the number of friends for 40 users on Facebook, and in the problem, I say we want to be 95% confident, and I give you the standard deviation. Okay, so let's go over here. All right, we want to run this confidence interval. All right, and this is going to be a z-based confidence interval. All right, and I'm going to talk at the end of the video about the difference between z and t, but for now, just know this is z, and we're going to go into one sample z. All right, our data. All right, so here we can either choose that our data is in a column like we have with Facebook friends, or we can choose summarized data. You'll notice for the next problem that we just have summarized data where we type this information in. But for right now, we have raw data, and we're going to select Facebook friends. Our known standard deviation is 53. All right, and the last thing we need to do is go under options and specify our level of confidence, which is 95%. All right, so again, notice you can choose 90, 95, or 99. We leave it on 95 and say okay. All right, so notice in our output here, we get our sample size, our point estimate. All right, so 130.8 is the sample average or point estimate. We get our standard deviation. We get the standard error of the mean, which is the standard deviation divided by the square root of the sample size. And then we get the 95% confidence interval. Okay? All right, so when you answer these on the quiz or the first exam, you're going to want to always use a complete sentence. All right, and I'm very picky about how this sentence is worded. All right, so let's take a look here at how this sentence should be worded. With 95% confidence, you can say the population mean number of friends is between 114.375 and 147.225 friends. All right, and that would be right there. That would be, let's highlight that. That would be our perfect answer for this Facebook problem. All right, so what happens when we start changing the numbers? All right, so what happens if we increase our sample size? All right, well, let's go back here to, let's just play here for a second. Go into one sample Z, and we'll do summarized data here. So let's say we've got 100 people. Let's say the sample mean is still 130.8 and our known standard deviation is still 53. All right, so all I've changed here from this first problem is the sample size from 40 Facebook users to 100 Facebook users. I'm going to leave confidence the same. What happens to the interval? Aha. So now the interval has gone from 120.412 to 141.188. All right, so notice that the interval shrunk or got smaller. All right. Similarly, what happens to the interval if you increase the confidence? All right, so let's go back to the first problem here, one sample Z, and we'll do a make similar. But now instead of 95% confidence, let's increase our confidence to 99%. All right, what happens? All right, now we are at 109.214 to 152.386. Compare this interval to our original interval. What happened? Well, obviously, the interval got wider. All right, so in other words, if you want to be more confident, you have to grab more numbers. Okay, so increasing confidence makes the interval wider. All right, let's do another example. All right, so here a college admissions director wishes to estimate the mean age of all students currently enrolled in a random sample of 20 students. The mean age is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years, and the population is normally distributed. Construct a 90% confidence interval of the population mean age. All right, so we're going to go into one sample Z. Here we have summarized data. Our sample size is 20 students. The sample mean age is 22.9 years. The known standard deviation is 1.5. All right, and under options, we're going to specify 90% confidence. All right, and so that's all there is to it in getting the interval. Now, for your final answer, we're going to say with 90% confidence, the population mean age of all students is between 22.348 and 23.452 years. All right. All right, moving into sample size here. Sometimes we want to kind of back into how many people we need to ask for a particular confidence interval width. All right, I will go ahead and tell you that if you take this margin of error formula right here and solve it for the letter N, you will get this formula here. All right, so we have just algebraically moved terms around to get this formula. Now, you do want this formula handy on your quiz and on your first exam because you will be calculating minimum sample size. All right, so let's do one of these, and let me go, and you'll either need a calculator or Excel. It's up to you what you choose to use. All right, let's see. You want to estimate the mean number of friends for all users on Facebook. How many users must be included in the sample if you want to be 95% confident that the sample mean is within 7 friends of the population mean? All right, according to this formula, we need a critical Z, we need a standard deviation, we need a margin of error, and we're going to be given some confidence. All right, so our margin of error, or our standard deviation rather, with the Facebook example is 53. All right, we're told here in the problem 95% confidence. The margin of error is how wide we want the interval. It is the number that follows the word within. So we look here and we see the sample mean is within, right here, within 7 friends. So our margin of error is 7. All right. Now the only thing we're missing to solve this is the critical z. All right, and this is where you either know the table or you know how to find these numbers in Minitab. All right, but for 95% confidence, the critical z is 1.96. All right, and now I am just going to plug all these numbers together, all right, into Excel to calculate this formula. So the formula says, all right, let's do this, equals, in parentheses, I have the critical z times the standard deviation divided by the margin of error, all squared. All right, and I get 220.2256. Now, how in the world are you going to survey 220.2256 Facebook users? And the answer is you're not. So like we've seen before in last week, what we're going to have to do here is round this number up. All right, so well, I don't know why it's, let's do this. Always round up. All right, and so our answer here would be 221 Facebook users are needed, all right, to have a confidence interval that's within 7 friends. Okay, moving right along into the t-distribution. All right, so let's minimize that back. All right, so what happens with the t-distribution? Why do we need the t-distribution? All right, so I think the easiest thing to do would be to look at this formula. All right, we're still going to calculate a sample average as a point estimate. We're still going to build a fence around that point estimate. The only difference is we're now using something called the t-distribution. All right, so we're going to have a critical t value instead of a critical z-score. And instead of having sigma in the numerator, we have this little s, which signifies we are going to have to use the sample standard deviation. Now, to make a very long statistical story as short as I can, let me just say that we are using the sample standard deviation in place of the population standard deviation. So we're picking up error. All right, S is not exactly equal to sigma. Okay, it's going to be off a little bit. Because we are picking up that error, we need to accommodate for that with a distribution that's not as precise as the standard normal distribution. In other words, we need a distribution that is still symmetric, but it has wider tails, meaning it allows for values further away from the mean. All right, so for the next few examples, we are going to calculate confidence intervals based on the t-distribution. All right, again, be patient with me. Let's go through these examples so you know what to do in Minitab, and then at the end I will talk about the difference between z and t. All right, first example here. You randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162 degrees Fahrenheit with a sample standard deviation of 10 degrees Fahrenheit. Construct a 95% confidence interval for the population mean temperature. Assume the temperatures are approximately normally distributed. All right, so this is going to be a t-based confidence interval. So we're going to go into one sample t. All right, I give you summarized data. We have 16 coffee shops. The sample mean is 162 degrees Fahrenheit. The sample standard deviation is 10 degrees Fahrenheit. And we want to calculate a 95% confidence interval. We say OK. And we get our confidence interval rather easily. All right, so what is our final answer? We say with 95% confidence, we can say the mean temperature of coffee at all coffee shops is between 156.67 degrees Fahrenheit and 167.33 degrees Fahrenheit. All right, let's do another one. You randomly select 20 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership's lot before it was sold. The sample mean is 9.75 days with a sample standard deviation of 2.39 days. Construct a 99% confidence interval for the population mean number of days the car model sits on the dealership's lot. Assume the days on the lot are normally distributed. All right, so we're going into one sample T. Again, we have summarized data. We have 20 cars. The mean is 9.75. The standard deviation is 2.39. And we want to be 99% confident. We say OK. We get our confidence interval. And we say with 99% confidence, we can say the mean number of days the car, we'll say the mean number of days all cars of this model sit on the lot is between 8.22 days and 11.28 days. Okay? So hopefully, my goal is that right now you're thinking, okay, calculating these confidence intervals and writing the sentence is very easy. What remains for you to understand is when are you going to go to one sample Z and when are you going to go to one sample T? All right. And the answer is here, if. All right, so the first thing you're going to look for is the variable normally distributed? If you say no, then you say, all right, I'm done with the problem. There's nothing you can do. All right. If you say yes, then you proceed. All right, the next thing you look for is the standard deviation. All right, if it is known, meaning it comes from the population or past study or is assumed, you use Z. All right, if it is unknown, all right, and if it's unknown, you must use the sample standard deviation, which means you're going to use a t-based confidence interval. All right, so let me pull this problem up. Let's take a look at this problem. You randomly select 25 newly constructed houses. The sample mean construction cost is $181,000 and the population standard deviation is $28,000. Assuming construction costs are normally distributed, should you use the normal distribution, the t distribution, or neither to construct a 95% confidence interval? All right, well, we are told that it's normally distributed. All right, so we can proceed. And then we are given the population standard deviation. Because we are given the population standard deviation, we are going to use Z. All right, and so we would go to one sample Z. We would choose summarize data. We've got 25 homes, the sample mean, the known standard deviation, and we are interested in 95% confidence. We say okay, and then we would, with our complete sentence, interpret this confidence interval. All right. I will put up some more information in this folder on distinguishing between Z and T, and then I will also be doing a video on the classwork, which helps delineate even more between Z and T.